Hey everybody, this is our third part of graphs of piecewise functions, and I'm going to do something a little bit unusual for me. I'm going to go into your assignment list in Delta Math and we're going to just do a problem. Now I've already screenshotted the problem into this box and I'll put the solution in here whenever we're done. But I thought the best way to show you how to do this would be actually go to the work we have to do and just work on it from there, okay? So I'm going to get right to it because I don't want this video to get too long here. And we're going to Delta Math. That's our problem right there. And it'll be easier to read from right here. It says, express the function graphed on the axis below as a piecewise function. And we have a template down here to enter our stuff in. And I'm going to show you the easiest part of this. And I'll start on the easy part because we like to make some progress when we can get it done easy. All right, so to start with, this thing this is a horizontal line. And by the way, both of these are linear. Okay, so it isn't so bad. If you hadn't had Math 1 in a long time, and you haven't, this is the horizontal line, y equals a number, a constant. Happens to be 2, right? So this is y equals 2. Well, we're dealing with f of x, so it's 2. It's that simple. For what? It goes from 3 to positive infinity. So we would say x is strictly greater than 3, right? That part's done. Now for the trickier part. Okay, when you're looking at these, well, we got to find the slope because remember this is an mx plus b. It's linear, so we need a slope and a y-intercept, and then we can write our little function in here. We can write the inequality right now. It would be x is what, less than -3, less than or equal to -3. It includes it because that dot. So that part's done. That's the easier part. Now, writing this function might be a little bit harder. So let's see what kind of slope we've got. Down 1 over 1. Down 1 over 1. So it's -x, or -1x if you like. Now the question is, what is the y-intercept? There's two ways of doing this. I'll show you their way, and then I'll show you another way you can do it just by counting blocks on the graph. But sometimes I've found looking at these that it goes below your axis where you can't see the intercept visually, and it might be troublesome. So let's locate this point right here. This is at, what, -3, +3. Let's remember that. -3, +3, with a slope of -1. So this thing goes through the point -3, +3. Right? And we know it's got a slope of -1. Okay, so one way to do this, if you remember, this is what they're going to show you in the Delta Math. If you remember point slope form, it says y minus y1 equals m times x minus x1. And you can write an equation of a line. Now, if you solve this for y, you just have m times x minus x1 plus y1. Right? Now we can plug our points in and we can simplify this. We'd have y equals, we put in our -1 for m, x minus -3 is x plus 3, and we're going to say plus that y1, that's right here, 3. So we're going to get -x minus 3 plus 3. So we're going to get, it's just -x, right? All right, so that's the way you would do it by hand. That's one way to do it. You could just write an equation of a line going through that point with that given slope. That works too. So let's make sure graphically that makes sense. Look, down 1 over 1, down 1 over 1, down 1 over 1. Yes, it goes through the origin. Or down 3 over 3. It goes through the origin, so I know that that's right. You can block count your way through it. I'm happy with that one. We're going to do one more. All right, this comes from what they call level 2. This is the second problem. It'll be in our example 4. And I think the reason they call it level 2 is it's got this little spot on the graph we're not used to seeing. And I'll kind of talk my way through this one, and we'll take care of one part at a time here. First of all, this is a linear line. This is just a point. So we'll take care of the linear line first because I think we just talked about that, and it shouldn't be too bad. All right, so we can see the y-intercept of this one is positive 3. And we can see that it's got a slope of down 3 over 1. So it's got a -3x and then plus 3. Oh, that was a goofy x. I don't know if it would have counted that. I got my caps lock. 3x plus 3. Let's double check that. I don't want to mess this up. Down 3 over 1. Yes, the slope is correct. Got a y-intercept of 3. Okay, so looks like we're coming from negative infinity to positive infinity, only leaving out one spot here at 2. So we can write, so for x is not equal to 2. That's the only place I'm not allowed to be. That's the hole in the graph. All right? Then this is going to be a little bit tricky. Then we want the horizontal line y equals 2, and we only want it if x is equal to 2. So that's the only place it exists, right there. And we'll submit this, and it's right. But anyway, watch this video a couple times if you have to. Remember, it's the constant 2 here comes from thinking of this as a line, which it's not. It's just that point. But if I make it just 2, 2, I define it with its domain of just 2 over here. Okay? So we know we got the ordered pair 2, 2, and that's really what this is. X, Y. And then this part here is pretty easy. You have a hole in the curve. Just leave that one point out, okay? Or that one spot, a hole in the domain. Anyway, I hope this was helpful. And good luck with these. Let me know if you have trouble. Thanks, guys.